Hey everybody, this is part 2 of our hyperbolas video. So I'm going to continue with the second example. And remember, so I had hyperbola, we want to put it in the form x squared over a squared minus y squared over b squared equals 1, or in the form y squared over a squared minus x squared over b squared equals 1. So to be able to identify what our transverse axis is. So right now I have 100 there, so and I need to get a 1 to be able to identify which version do I have. So go ahead and divide. What we're going to do is divide everything by 100, divide both sides by 100. So dividing the left by 100 means each term. So I'm going to get y squared over 4 goes into 125 times, and this will be x squared over 4 equals 1. So it looks like I have this version, which now we have to decide what's our transverse axis. Do we have a horizontal or a vertical transverse axis? So focus on which one is the positive one. Y squared over 25 is the positive. So we're going to have a vertical transverse. And so identifying whether you have a vertical or a horizontal is really helpful because this tells us what our vertices look like. And so our vertices will look like, because it's vertical, that means that the x is 0, and then we have plus or minus a. So what's a? And so this is again where it helps to write it as, so I'm going to write it over here, x squared over 25. Well, what am I squaring to get 25? I'm squaring 5. And that was supposed to be a y squared. And x squared over 4. What am I squaring to get 4? We're squaring 2. And so that means that my a is 5 and b is 2. So the vertices are going to be 0 and plus or minus a. So plus or minus 5. And because this has a vertical transverse axis, so that means that our hyperbola is going to open. It has vertices there, right at a and at minus a. So it's going to open vertically. So up and down. So that's what it means. So when we're looking for a vertical transverse axis, it's going to open up and down. Horizontal transverse axis is going to open right and left, like the example we did in the previous video. Now what about the foci? The foci, because we have a vertical transverse axis, is 0 plus or minus c. So what's c? So over here, right, we're going to have c, this will be negative c, and that will be c. So that's why we have 0 for the x, and then plus or minus c for the foci. And so to find c, we call that c squared is equal to a squared plus b squared. So in this case, it's going to be c squared is 25 plus 4. So c squared is 29, which means c is plus or minus the square root of 29. So our foci here would be 0 plus or minus the square root of 29. The next thing to find are asymptotes, although at this point you could draw the hyperbola by doing the rectangle and the asymptotes and then label them. But I'm going to go ahead and find the asymptotes anyway. So the asymptotes, because this is a vertical transverse axis, our asymptotes are y equals plus or minus a over bx. So what does that look like for our example? It's going to be y equals plus or minus a. A is 5, so 5 over b over 2x. And so now with all this information, we can graph our hyperbola. So let me graph it over here. Okay, so I'm just going to rewrite it so that I have it visible, so it's y squared. So y squared over 25 minus x squared over 4 equals 1. And so I know that A is 5 and B is 2. So when we go sketch it, because A is underneath the 5 squares underneath the y, that's going to be a y value. So 1, 2, 3, 4, 5, and -5. So these are the vertices. So my hyperbola opens up and down. And B is 2, so we're going to go 1, 2 on the x, and -2 because the b squared is underneath the x, so those are x values. And then we draw the rectangle to the best that you can. If you have graph paper, it might be better to do it with graph paper. And now the asymptotes, right, plus or minus 5/2 x, they go through the center of the hyperbola and then through the corners of our rectangle. And again, I cannot draw a straight line. Okay, something like that. And now that we have, so our asymptotes, they guide our hyperbola. And so this one will be y equals 5/2 x. And this one will be y equals -5/2 x, which they're not too bad to draw, right? The slope, if you decide not to draw the box, this is n equals 5/2, so you can still do it by the slope, rise over run. So from 0, 0, I'm going to go rise. So you go up 5 and over 2. So that puts you at that corner. Or you can go down 5 and over 2. So that puts you at that corner, and then you draw the line. For the other one, n equals -5/2, then you will go down 5 and over to the right 2, or you go up 5 and over to the left 2, and that gives you the other one. So you can still do it just based on the slope. You don't have to necessarily draw the box, but the box helps just kind of guide them. And because again this had a vertical axis, vertical transverse axis, our hyperbola, now we can draw it. So it goes from the vertex, and just like with any graph, if it has an asymptote, it follows the asymptote. And so that's our hyperbola. So we have the asymptotes, we labeled the vertices. So doing it correctly, this vertex up here will be 0, 5, and this vertex down here will be 0, -5. What else do we need to label? We need to label the foci. The foci was plus or minus the square root of 29. So where is that? So use your calculator to figure out what the square root of 29 is. Or you can think of the square root of 25 is 5, and the square root of 36 is 6. So the square root of 29 is somewhere between 5 and 6. That when you do it on your calculator, you get 5.38. So going into our graph, so this is 5, so 5.38. So this one is very close. So notice that the hyperbola is a little bit narrower than the other one we did, and that's because the foci are closer to the vertices. So this will be 0 and positive square root of 29, and then down here, this one will be 0 and negative square root of 29. And now that hyperbola is finished. So always make sure that you label your vertices, your foci, and your asymptotes. All right, so let's move on to the next example. So my next example is find an equation of the hyperbola that passes through the point 4 square root of 18 and has a foci of plus or minus root 10, 0. So what's our goal? The goal is to come up with the equation. So we have two versions of the equation. It can be a x squared over a squared minus y squared over b squared equals 1, or it can be y squared over a squared minus x squared over b squared equals 1. So the main thing is, how do we decide which one it is? This one has a horizontal transverse axis, whereas this one has a vertical transverse axis. So how do you know from the problem which one do we have? Well, the foci are given. So notice that the foci says plus or minus root 10, 0. So the x is given and the y is 0. So that means that the foci is on the x-axis. So that means we have a horizontal transverse axis. And so we're looking for this equation. So we want x squared over a squared minus y squared over b squared to be 1. And so now how can we use this information given? So I know it passes through the point 4 square root of 18, then we know the c. So let me write that down. So we know c is equal to the square root of 10 based on the foci, right? Because we know that the foci is usually given as plus or minus c comma 0. So I know c is the square root of 10, and we also know that c squared is equal to a squared plus b squared. So that will help us with something. So I can say c squared, so 10, is equal to a squared plus b squared. I'm going to keep this here and see how that helps me over here. We know that it goes through the point 4 square root of 18. So using, how can we use this? Right? This is an x value, this is a y value, so plug it in. So I'm going to have 4 squared over a squared minus square root of 18 squared over b squared equals 1. And so what do we have? We have 16 over a squared minus 18 over b squared equals 1. My goal is to find a and b. How do I do that? I'm a little bit stuck. Well, that's where we're going to bring this in. So I can solve for a squared or for b squared and plug it into one of these. But I'm going to get rid of the denominators first so that I don't have to deal with plugging anything into a denominator. So multiply by the LCD. The LCD here is a squared b squared. So multiply both sides by a squared b squared. And so when you multiply this by this, the a squares cancel. So I'm going to be left with 16 b squared minus, when you distribute it over here, the b squared is going to cancel. So I'm going to be left with 18 a squared equals a squared b squared. So now I don't have denominators. So now we can use this in here. So solve for one of them, either a squared or b squared. I'm going to solve for a squared. So I know that 10 is equal to a squared plus b squared, which means a squared is 10 minus b squared. And plug that in for wherever I see an a squared. And then we're going to solve for b. So let's see. We are left with 16b squared minus 18a squared, so 10 minus b squared times b squared. Sorry, equals, I forgot my equals there, equals a squared b squared, so 10 minus b squared times b squared. And let me just fix this 16 real quick because my 6 looks too much like a b. And so what do I have? So I'm going to have 16 b squared minus 180 plus 18 b squared equals, multiply the b squared here, so 10b squared minus b to the 4th. Like, that does not look very fun, but let's see. Let's work through it. combine like terms. So I'm going to have, what is this? So that'll be 34 b squared minus 180 equals 10b squared minus b to the fourth. And set it equal to 0. So subtract 10b squared from both sides and add b to the fourth. So what do we end up with? I'm going to end up with b to the fourth plus 24 b squared minus 180 equals 0. Here those cancel. So this has the form of a quadratic. Notice that 4 is double the 2 there. So this is a quadratic equation. And hopefully we can factor it. And if you can't factor it, then you use the quadratic formula. And so two numbers that multiply to negative 180 and add up to 24. And just from my knowledge of trig, I know that 180 is 30 times 6. So let's try that. So b plus 30 and then b squared minus 6. So yeah, 30 times 6 is 180 and 30 minus 6 is 24. So this one works. And use the zero product property. So b squared plus 30 equals 0, or b squared minus 6 equals 0. This one tells me that b squared is equal to negative 30, which can't happen, right? You can't have a number squared giving you a negative number. So that one is not possible. And this one says that b squared is equal to 6, and that is okay. So b is going to be the square root of 6, but we are looking for a squared and b squared. So I don't have to solve for b. I can just leave it as b squared because this is what I want. I want x squared over a squared minus y squared over b squared. So I just found b squared is 6. So I can almost write my equation. Right? So our goal was to get x squared over a squared minus y squared over b squared equal to 1. We just found b square equals 6, so I can replace that there. How do I get a? Well, remember, we had solved for a square up above. A squared was 10 minus b squared. So since b squared is 6, that means that a squared is 10 minus 6. So a squared is 4. And so now we can finish our equation. So the equation of this particular hyperbola is x squared over 4, because a squared is 4, minus y squared over b squared. B squared is 6, equal to 1. And that's our equation. Now, how do you check it? We'll find the foci and see if in fact the 0.4 square root of 18 is in there. Right, so check. So it is 4 square root of 18 in the hyperbola. So plug it in. So I'm going to have 4 squared over 4 minus y squared. So y is the square root of 18 squared over 6. Does that equal, in fact, 1? So we're going to get, what is this, 16 over 4 minus 18 over 6. And does that equal 1? Get a common denominator or reduce. So if you reduce, right, this becomes 4 minus 6 halves. Does that equal 1? And get a common denominator. So common denominator is 2, so I'm going to get 8 halves minus 6 halves, which is in fact 2 halves, which is 1. So it checks out. And then another way you could check it is the foci. Do you get plus or minus the square root of 10? And you will see that in this case you do. Okay. Hopefully that helped with, this was a little bit difficult, a little more difficult than usual, for finding the equation of a hyperbola, but I hope that going through that helps you with some of the slightly simpler ones. Email me if you have any questions.